Hi guys, this is Mrs. Gessler, and in this video we're going to talk about how to tackle writing a name or a formula if you don't already know if it's ionic or covalent. And we're going to have, we already talked about naming ionic and covalent compounds and writing their formulas. So I just have one sheet of Cornell paper, and then I have here my notes on how to write covalent and how to write ionic compounds, because there's no need to write all that again, right? Okay, so let's get started. Our topic is mixed naming and formula writing. Don't forget your name, date, and class period. And we have one essential question, and that is, how do I write the name or formula of any compound? And in order to be able to do that, the first thing you have to do, the first step, regardless if you're going name to formula or formula to name, I'm going to write either way. The first thing you have to do is determine if it's ionic or covalent, because they have separate rules, and once you know if it's ionic or covalent, then you just follow those rules. So the first thing we have to do is figure out if it's ionic or covalent. This we tackled in Objective 5, I believe, so if you don't remember that specifically, then you can look at Objective 5. And a refresher here, it is ionic if it is a metal plus a nonmetal or nonmetals. Okay, the polyatomic ions are part of an ionic compound. They also have covalence in them too. It is covalent if it is a nonmetals only. Okay, so again, the periodic table is where you would look to find that information. If you know it's a metal or a nonmetal, then you can find out whether or not it's ionic or covalent. Okay, so the next step is to just follow the rules appropriately. I know that seems easy, difficult, but well, easy, I don't know. But that's all you have to do, okay? So there's some special notes that I wanted to go over. These are some common mistakes that kids make when they have mixed up ionic and covalent compounds, the common things that happen. When writing names, one of the things that people do is they use prefixes on the ionic compounds, so there are no prefixes if it's ionic. If it's ionic, there are no prefixes. And then the other problem that people have when they write ionic names is the Roman numerals are for short metals, those transition metals only. Okay, don't use them any other time. They're only for the short metals. And then for covalent compounds, nobody cares about the charges, and there are never Roman numerals. So we don't ever have those Roman numerals. Remember, those use the prefixes, okay? And the prefixes is what we use for the covalent compounds. And then when you're writing the formulas, some common mistakes here. Whenever you write an ionic formula, you have to find the charge. Find the charges. You have to find the charges. The charges will tell you how many of each there are. If you don't find the charges, you won't be able to know how many of each there are. So you have to find the charges. That is a necessary step. I know it makes it time consuming and difficult, but it's got to happen. Okay? And then with the covalent, all you have to do is use the prefixes. Nobody cares about the charges here either. Okay? So it's pretty simple. That's all there is to it. I've got my notes here, and I've got a few examples that we'll take a look at. Okay, so here we go. Carbon tetrachloride. I have carbon, and this chloride is chlorine. So I've got carbon and Cl. When I find those on my handy periodic table, carbon is here and chlorine is here. Those are both nonmetals, so it is covalent because they are both nonmetals. Okay, the other giveaway is this tetra here, which is a prefix. Prefixes are only for covalent compounds, so if you see a prefix, you can know it's a covalent compound. So the next thing I have to do to write the formula is I don't have any prefixes, so there's only one carbon. Tetra means 4, so this is CCl4. Okay, that was a nice, easy covalent one, right? Now I've got tin 3 nitride, okay? Tin 3 nitride. Now the first clue that I can know that this is an ionic compound is because it has a Roman numeral, and I know that Roman numerals are only in the ionic compound, so it has to be ionic. The other thing I can do is I can look this up. Tin is right here. Oh, it's on the edge of being a metal, okay? Here's my metalloids right here. Tin is in fact a metal. So that's the other way I can know metal and a nonmetal. Okay, so to write this formula, it's ionic, I have to find the charges. Okay, so I'm going to start with tin. Tin has this 3, that Roman numeral tells me the charge, so I know it had 3 dots. Nitride used to be nitrogen. Nitrogen is in this column right here, which means it has 5 dots. 1, 2, 3, 4, 5. And so what's going to happen here is this tin is going to say, here you go, nitrogen, I'm done. And then my tin becomes plus 3 and my nitrogen becomes minus 3 with all of its little dots around it. And then those guys just get written close together. But it looks like I only need one of each of those. So then my formula would be SNN. Again, I had to find the charges to figure out how many there were. I could have made an assumption, and I would have been right here if it was 1 and 1, but I don't know. Some people like to put this Roman numeral as the subscript. They like to write SN3, and no, that's wrong. Don't do that, okay? All right, Mn2S, although that S looks an awful lot like a 5. Mn, oh, it's right there next to the shiny part. Mn is a metal, S is a nonmetal. This must be ionic, because it has a metal and a nonmetal. Okay? Mn2 is a short metal, which means I've got to find the Roman numeral here. So I've got to figure out what the charges are. S is over here in my column 6 here, so it has 6 valence electrons. 3, 4, 5, 6, and I needed 2, whoops, MNs. Now this sulfur needed 1 from each of these, so each of these MNs must have only had 1 on it. So when I write the name here, this was MN plus 1. That means my Roman numeral equals 1. Numeral. I think I got some extra letters in there. So this is, Mn is manganese. And manganese 1 for that charge, and then sulfur becomes sulfide. So there's my name right there. Okay. Next one here, I got to figure out if it's ionic or covalent first. P and O, those are both nonmetals, so that makes it covalent. They're both nonmetals. Both nonmetals. So then I need to figure out what the prefix is going to be. 2 is di and 5 is penta. So this is diphosphorus, penta, and the penta and the oxygen, the A and the O come together to just be an O, and then I change oxygen to oxide. So diphosphorus pentoxide. Okay, so all I did, remember the first thing I did was figure out if it was ionic or covalent. Don't start applying rules because they're very different how you name those. If you need more practice, there's plenty in the homework. If you need help, make sure you ask your teacher. Thanks for watching.